Today we're going to learn how to use the zero and negative exponent rules. You should be on page 42 in your notes packet. Whenever you have 0 as an exponent, what really happens is that you eliminate your base and your exponent and it becomes 1. So a raised to the 0 power is actually equal to 1. If 7 is being raised to the 0 power, then it equals 1. If negative 5 is being raised to the 0 power, it equals 1. If 3.72 is raised to the 0 power, it equals 1. For negative exponents, remember I've told you before that we never actually want to have a negative exponent. They exist, but we want to try to get rid of them. So, anytime we have a negative exponent, so for example, a is being raised to the n power or negative n power, what we want to do is flip this to its inverse. So because a is technically over 1, even though we don't see it, but we know that every whole number is over 1, we can take a and move it down to the denominator. And as soon as we move it from the numerator to the denominator, it becomes positive. Well, that would leave us with nothing in the denominator, so we have to put something there, which means we would replace it with 1. So a to the negative n power would become a, or 1 over a to the positive n power. As soon as you flip it, that exponent becomes positive. Examples of this are positive 3 raised to the negative 4th power. Well, to get that exponent to be positive, we need to flip it. So right now, technically it's in a numerator, so we need to put it in a denominator. So it's going to be moved down to the denominator and then it becomes positive. So this becomes 1 over 3 to the positive 4th power. Now we can simplify this further by taking 3 and raising it to the 4th power by doing 3 times 3 times 3 times 3. And that would give us 81. So 3 to the negative 4th power is the same as 1 over 81. For negative 7 to the negative 2nd power, we want to take this and we want to flip it. So we're going to put this in the denominator, and that's going to leave us with 1 over negative 7 to the 2nd power. Well, we can again simplify this further by solving negative 7 to the 2nd power, which is negative 7 times negative 7. Well, that would give us positive 49. So this would become 1 over 49. So let's simplify each of these expressions. 7 to the negative 2nd power needs to be changed. We have a negative exponent, which we don't want, so we need to put this in a denominator. As soon as we put it in the denominator, it becomes positive. But we can't leave nothing in the numerator, so we're going to put a 1 there. Well, we can simplify that further by doing 7 to the 2nd power, which is 7 times 7, which would give us 49. 13 to the 0 power is going to give us 1, because we know that any number raised to the 0 power is 1. For number 3, we have 1 over negative 4 to the negative 2nd power. Remember that if we want to get rid of a negative exponent, we need to flip it. Now, we have been flipping all of them into the denominator, but this one is already in the denominator. So to get rid of this, we actually need to move it to the numerator. So I'm going to move it to the numerator, and that's going to be negative 4 to the positive 2nd power, because as soon as I move it, it becomes positive. Now that would be over 1, but if something is over 1, we don't actually need that. So we can get rid of that piece, and then we can solve negative 4 to the 2nd power. Because that negative 4 is in parentheses, this means that negative 4 is being multiplied by itself 2 times. Negative 4 times negative 4 gives us positive 16. Next, we have 9 to the negative 1st power. Well, we don't want a negative exponent, so we need to get rid of this by moving it. Right now, technically, it's in the numerator, so we need to move it to the denominator. As soon as we move it to the denominator, it becomes positive, and we need to put a 1 in our numerator. Well, 9 to the first power is just 9, so this is like saying 1/9. Number 5 says -5 to the 0 power. Well, remember that any number raised to the 0 power is 1. However, you need to be careful with this one. The 0 is on the 5, so 5 is being raised to the 0 power. If this had said -5 in parentheses raised to the 0 power, then the -5 itself is being raised to the 0 power, which means that anything raised to the 0 power becomes 1. In this case, when you have an exponent and there are no parentheses and there's a negative number, the exponent is actually only on the positive number itself. And the negative number is telling you to find out what this equals and then tell us the negative value of it, or the opposite of it. So 5 to the 0 power is 1, but that negative tells us that this is a -1. Number 6 says 2 to the -5th power. We want to flip our -5 down to the denominator, so this is going to become 2 to the 5th power, and we're going to put a 1 here. Well, 2 to the 5th power means 2 times 2 times 2 times 2 times 2, which gives us 32. And we're going to keep our 1 in our numerator. Number 7 says -4 to the -2nd power. So remember that -4 is in parentheses, so that means that that exponent is being applied to the negative as well. So we need to get rid of our negative exponent, and we're going to do that by flipping this down to the denominator. So now it becomes -4 because this negative doesn't change. The only thing that changes is the negative on the exponent. So -2 becomes an exponent of +2, and we're going to put a +1 in our numerator. Well, we can solve this by doing -4 times -4, which is +16. So this is 1/16. Now, if this had been -4 to the 2nd power and there had been no parentheses, then this really is telling you to do 4 to the 2nd power and then tell us the opposite. So 4 to the 2nd power is 16, and the opposite of 16 is -16. So had there been no parentheses here, then this actually would have ended up being a negative number. So for number 8, you see that these look the same, but they are different. So we're going to take our -4 to the -2nd power, and we're going to put that in our our denominator, and then our 2nd power becomes positive. That is over 1. Well, as soon as we flipped it, that was positive, so now we can do 4 times 4, because remember, the exponent is only on this base. And if there are no parentheses, then that means that this is telling us to do the opposite of 4 squared. Well, 4 squared is 4 times 4, which is 16, and the opposite of 16 is negative. So this is +1 over -16. Remember, I never really want to have a negative number as just the denominator, so I want to change this so I can tell that the whole fraction is either positive or negative. If I have a +1, and technically our fraction bar means divide, so if I take a positive number here and divide by a negative number in my denominator, a positive divided by a negative is a negative. So that means that this is really 1/16 and that the whole fraction is negative. Number 9 says 7xy to the 0 power. Well, if I look at this, I need to just take out the pieces that I know that I can work with. I can't do anything with 7 or x, but y is being raised to the 0 power. I know that anything raised to the 0 power becomes 1. So 7x means 7 times x. And then when I have the y, that also means times y to the 0 power. but y to the 0 power becomes 1. So really this is like saying 7 times x times 1. Well, I would combine 7 times 1, which is just 7, and then times x means that I would have just 7x. Number 10 says 1 over m to the negative third power. Remember, I never want negative exponents, so I want to take this m to the negative third power and move it to the numerator to make that positive. Well, as soon as it flips to the numerator, that becomes m to the positive third power. Technically, that's over 1, but we don't need to have anything being over 1 because m to the third power divided by 1 is still just m to the third power. For 5d to the negative fourth power, I want you to pay attention because this can be a little bit tricky. The negative fourth power is only on the d. It is not being applied to the 5 because there are no parentheses here showing that everything is being raised to the negative fourth power. So technically 5 has an invisible exponent of 1. Because 5 has that exponent, 5 does not need to be moved because that is a positive exponent. However, d does need to be moved to the denominator so that we can get rid of its negative exponent of negative 4. So we're going to move d to the negative fourth power down to the denominator, and as soon as we do that, that exponent turns to a positive number. So this becomes 5 over d to the fourth power. For m to the negative seventh power, n to the 0, we need to start with our negative exponent, so we know that m needs to be moved down to the denominator. And as soon as we move it, that negative 7 becomes positive. N to the 0 needs to be simplified. Well, we know that n to the 0 power, anything to the 0 power, is just 1. So we're left with 1 over m to the 7th power. For e to the negative third power, f to the 5th power, we see that f to the 5th power isn't a problem. That is a positive exponent, so there's nothing that we need to do with it. But e needs to be fixed so that we have a positive exponent. We need to take that negative 3 and turn it into the denominator, so we're going to put e to the positive third power. F to the 5th power can stay where it is, so it's f to the 5th over e to the 3rd. For 3ab to the negative 8th, 5c over 5c, the only problem that we have here is this negative exponent of 8. So 3 and a will not change, 5 and c will not change, but b to the negative 8th needs to be moved. So it needs to be flipped into the denominator, and as soon as it flips, it becomes a positive exponent. For 9x to the 0, y to the negative 7th over z to the negative 3rd, we need to start with each one of these. So if we start with 9, we know that 9 has an invisible exponent of 1, and there's nothing wrong with that, so that can stay exactly as it is. Well, x to the 0 becomes 1 because any number raised to the 0 power is 1. Well, this really says 9 times x to the 0, so really this says 9 times 1. But 9 times 1 is just 9, so this kind of just cancels itself out. Then we have y to the negative 7th power. Well, we want to get that to be a positive exponent. So what I'm going to need to do with this is move it to the denominator. As soon as it moves to the denominator, that y to the 7th becomes positive. Now we also have z to the negative 3rd power. And since z to the negative 3rd power is in the denominator, to fix it, I'm just going to take it and move it to the numerator. And as soon as it moves to the numerator, it becomes a positive 3rd power. So my solution is just 9z to the 3rd over y to the 7th. For number 16, I have 2 to the negative 3rd, m to the 5th, n to the negative 9th. Well, we need to flip everything that has a negative exponent. So 2 to the negative 3rd needs to move to the denominator and become 2 to the 3rd. N to the negative ninth also needs to be moved to the denominator, and it becomes n to the ninth. M to the fifth had no problems, so it can stay right where it is. So we have m to the fifth over 2 to the third n to the ninth. Well, we can take 2 to the third and simplify that by doing 2 times 2 times 2, which is 8. So we can keep m to the fifth and then change 2 to the third to 8, and then n to the ninth would stay n to the ninth.